So for motivation, let's try to see how to find out area between these two parabolas, where the one parabola is given by y equals to 2 minus x squared, which is the one colored in red, and y equals to x squared, which is colored as blue. So the area between these two curves are basically this shaded region, and we want to find out what is the area between these two curves. So note that if you have two functions, so let's take f of x, and so this be f of x, and let's take another function, say g of x. This is your g of x. Then what is the, so we want to compute area between these two curves, right? So suppose we want to basically be able to compute this area, right? Now notice that what does integral a to b f of x dx gives? So integral a to b f of x dx gives area below the, what, area below the f of x. So it gives you all this whole area. So let me use another color pen. So it gives you all this area, right? Essentially gives you this area here, right? So it will give you the area below the curve. Now clearly it's slightly outside the line, so so integral a to b f of x dx represents this area shaded in yellow, and out of that, if you remove integral a to b g of x dx, so what is integral a to b g of x dx? That represents the area below the g of x, and then so you get this shaded region as your area. All right, so this is the, so area between these two curves is given by, so this region, let me shade it with another pen. So this region is given by, area between these two curves is given by integral a to b f of x dx minus g of x dx. So I can write this in short as, I can bring out the integral. So I have a to b f of x minus g of x dx. Now one may argue, what if the one function is above? So suppose you say, well, the one function is above the x-axis and the other function is below the x-axis. So let this be g of x. In that case as well, you can, the area between these two curves can be found out in the same way. Well, how to see the proof of it? You add a big enough constant, so this will move up, right? So if you add big enough c, you will see that this will be f of x plus c. And then you will have, say, this is going to be g of x plus c. And this area between these two curves will remain the same. And what is the area between these two curves? Is going to be, this area is going to be integral a to b fx plus c minus g of x plus c dx, which will give you same as integral a to b fx minus gx dx. So this is how you compute the area between the two curves. So you have upper curve minus the lower curve, okay? So let's look at it, result now. So if you have f and g as two continuous function, and f of x is greater than or equal to g of x for all x in b. This is a key important part, okay? This is key important. This is the key part. The area A bounded by y equals to f of x and y equals to g of x is between the lines x equals to a and x equals to b. So this is how the region x looks like. This is given by integral a to b fx minus gx dx. Okay, so this is how you find the area. So areas will always be positive, all right, in these examples. So let's do the following problem. So y equals to 2 minus x squared y equals to x squared. So you're not given bound between a and b. So you want to see where they intersect, and you want to find out the area bounded by this. So if you look at the area bounded, this is the area bounded by them, right? So the area bounded is this area here, right? So first things to do. So what are the steps involved? So step one, steps. So step one, irrespective of whether the graph is given to you or not, you need to determine what? Determine the endpoints, right? You need to determine where are you going to integrate from. Step two is to determine which one is upper function, B, upper function, and consequently the lower function. I mean, if you know what is the upper function, then you automatically know what is the lower function. And third, you need to basically write down the integral. So the integral will look like left endpoint to right endpoint. So these are the limits. You have upper function minus lower function. And since you're integrating with respect to x, in this case it's dx. If you're integrating with respect to y, then it's dy. Okay, so let's do this problem now. So what do we get in this case? So in this case, we get, first we need to compute the endpoints, yeah, without the graph. So think as if the graph is not given to you. So let's compute this. So we need to compute the intersection. So determine intersection points. So how do you determine intersection points? You basically equate them. So at intersection point, x and y coordinate both are going to be equal, right? So you can basically say 2 minus x squared equals to x squared. So I'm equating that y coordinate should be the same. So this implies 2 equals to 2x squared. This implies x squared equals to 1. This implies x squared minus 1 equals to 0. This gives me x plus or minus 1, x minus 1 equals to 0. This gives me x equals to plus or minus 1. So now you are in the interval. So the intersection points are decided. Now you're from minus 1 to 1. Now you have to decide which one is upper and which one is lower. So how do you decide that? You just take any point between minus 1 and 1. Let's take 0. So when you put 0, substitute in this function, y equals to 2 minus x squared. What do you get? When you substitute 0, you'll get 2 minus 0 square, which is 2. If you substitute in the second one, you'll get 0. So of course, the upper curve is upper curve or upper function is y equals to, or is 2 minus x squared. If you want to choose to call it f of x, you can go ahead and call that. So therefore, the integral area is going to be minus 1 to 1 upper curve minus the lower curve dx, which is going to be minus 1 to 1 2 minus 2x squared dx. Now this is a what kind of function? This is an even function, so it helps us to simplify. So you get 2 times 0 to 1 of 2 minus 2x squared dx, and the integral is going to be 2 times 2x minus 2 by 3x cubed 0 to 1, and when you put 1, you get 2 times 2 minus 2 by 3, which is 6 minus 2, which is 4. So 4 times 2 is 8. So 8 by 3. So this is how you compute the region. Does that make sense? Okay. So let's move ahead and try to do the following problem. So find region bounded by y equals to x and y equals to 6 minus x squared. So first thing is we'll compute the points of intersection to determine the endpoints. So 1, intersection. So now to compute intersection, you either equate the x coordinates, x's or y's. So we'll equate y. So we get x equals to 6 minus x squared. This gives me x squared plus x minus 6 equals to 0. This is a quadratic equation. The solutions are x equals to -3 or x equals to 2. Now we need to decide, so to determine the upper function. So basically take -3 to 2 and take any point of choice in between. So let's say 0. At 0, let's substitute 0 in the first one, you will get 0. If you substitute in this one, you will get 6 minus x squared. So upper function is 6 minus x squared. Then the lower function automatically is x. So now let's write down the integral which computes the area. So area is going to be -3 to 2, 6 minus x squared, the upper function, minus the lower function. So now we want to compute this integral. So how do we go about it? So this can be written as 6x minus x cubed by 3 minus x squared by 2 minus 3 to 2. This is going to be 6 times 2 minus 2 cubed by 3 minus 2 squared by 2 minus, now you substitute the lower limit, 6 times minus 3 minus of minus 3 cubed by 3 minus of minus 3 squared by 2. And then when you simplify, you will see that the answer is indeed 125 over 6. Okay, so this is your answer. All right, now let's consider the following problem. Find the area of the region bounded by what? By y equals to x by 2 and y equals to 8 minus x squared. So if you look at the upper curve in this region, so upper curve behavior changes. In this region, the blue is the upper curve, this is upper, and this guy is lower curve. In this part here, however, this curve here, this is upper, and then the same curve in modification would give us the lower curve. Yeah, so you have to break, if you want to do this problem, you have to break this part into two, break this into two parts. Okay. However, now we can do the following. If we interchange, if we swap x and y, so think about the same image, but just swap x and y. So you can see that this will look like, if we swap x and y, this will more or less look like this. And in that case, you can have a proper upper curve and lower curve, right? So the upper curve is replaced by the rightmost curve, and the lower curve is replaced by xmost curve. So early on, you are looking at f of x less than equal to what? Sorry, you're looking at, my bad. You're looking at g of x less than equal to f of x, right? So you're comparing the y value. So this y value for this curve is less than equal to y value for this curve. Now, if you swap them, then you are looking at x equals to f of y. So let's use a different notation, right? So x equals to h of y, and x equals to, say, p of y. In that case, what should happen? You are going to see which is the rightmost and then subtract the leftmost, right? So rightmost minus the leftmost. And then integration again. This will be in what? In terms of, this will be the values of y, right? Y values and values. Okay, and then integration is with respect to dy. All right, so we'll have the following theorem. So suppose A is bounded by the curve x equals to f of y and g equals to x equals to g of y, and the lines y equals to c and y equals to d. And f and g are continuous with f of y greater than equal to g of y. So how does it look like? It looks like the following. So you have here, you have f of y, and this is going to be greater than g of y, because you're comparing the x values, right? So x value of f is bigger than the x value of g. And suppose this is from C to D, and you're looking at this area, then the area is going to be C to D, f of y minus g of y dy. Okay, so the roles of x and y are interchanged here. So let's now do the problem we had early on. So find area bounded by y equals to x by 2 and y equals to 8 minus x squared. So again, first step is always to compute the intersection point. So what shall we do? Compute intersection. So again, intersection can be found by just equating the values. So which value shall we equate? It doesn't matter which value you equate, but in the end, you're looking for y values. So let's basically say here we have 2y equals to x, and then take this value and substitute in this one. So we get y square equals to 8 minus 2y. So substitute this into here. So we get y plus square plus 2y minus 8 equals to 0. So we get y plus 4, y minus 2 equals to 0. Therefore, y equals to negative 4, or y equals to 2. Yeah, that you can really see from the graph as well. But again, you may be asked to draw the graph, but you're not reading the values from the graph. You are supposed to draw. You're supposed to find the computation of, you should do the intersection points, compute the intersection points, okay? So now let's go ahead. So now what is the rightmost curve? So rightmost curve is, so rightmost curve is, or the, so rightmost curve is what? Let's take the value between minus 4 and 2. Say 0 for y. So if you put 0 for y, you get x equals to 0 for the first one, And in this case, you'll get, when you put y equals to 0, you get x equals to 8. So the rightmost curve is x equals to 8 minus y squared. This is how you're supposed to write the function, right? You're supposed to write x equals to f of y. Second one is leftmost curve, or left curve, then x equals to what? 2y. This is your g of y. So therefore the area is going to be integral minus 4 to 2, 8 minus y squared minus 2y dy. So let's compute this integral. So this is going to be 8y minus y cubed by 3 minus y squared minus 4 to 2. And what is this value? And this turns out to be 36.